All right, so in today's lesson, I'm going to be teaching you how to simplify square roots with negative radicands. So recall that when we talk about a square root, we're talking about the radical symbol, and when we say the radicand, we're referring to the expression under this radical symbol. So notice this radicand is -1, so it's going to be a little bit different than what we were doing the previous 2 days with square roots of positive numbers. So new to you will be understanding that the square root of -1 is actually the imaginary number I. And notice I'm writing it italicized. And it's just so you don't accidentally write it and it look like a 1. So the number I, recall that the first week of school we talked about the complex number system. And in the complex number system, you had two types of numbers. You had real numbers and you had these complex or imaginary numbers. So if you remember in your notes, we did all these examples of imaginary numbers like 3i or 2 minus 4i. So the numbers I are numbers that exist on the z-axis. So I know you already know that when we look at this, we would call this an x and a y axis, and that it is flat, meaning it's in 2 dimensions, like a piece of paper is flat. But in order to have height or create depth, we need a third dimension. So I'm going to draw this little diagonal axis through here, and we're going to call it the z-axis. So imaginary numbers exist on this axis. Without imaginary numbers, we would not be able to look at things in 3D, like on a computer. And if you've ever used a 3D printer, then it has an x-axis and a y-axis, and a z-axis is the one that goes up and creates that extra dimension. So imaginary numbers are important, but the value of I is equal to the square root of -1. And this concept is going to help us simplify when we have square roots of negative numbers. So feel free to hit the space bar and pause at any time. If you are listening, put a star beside A in your notes. So when we look at the square root of -7, we have to recognize that this can be broken down into -1 and 7. So the square root of -1 times the square root of 7. Well, we know from this rule up here that I is equal to the square root of -1, so we can substitute I in its place. Well, the square root of 7 is an irrational square root of a non-perfect square, so square root of non-perfect square, which means we can't simplify it any further in this case, so we simply bring it down. And we leave our answer as I square root of 7. Always putting the I in front so that it doesn't accidentally get interpreted as being behind the 7 and underneath the radical. So 7 is a prime number. We're not going to be able to simplify it any further. If we take a look at B, same thing. We have an 11, which is a prime number. Its only factors are 1 and 11. None of those factors are perfect squares. So I don't do this every time I do a problem. What I want you doing is to think of this as taking the I out and putting it out front and making that positive. Therefore, our answer would be I square roots of 11. So that's not hard at all, right? Just take your negative out and put an I in front. Same for C. 31 is also a prime number. Its only factors are 31 and 1. So again, put an I out front, making it positive, but because we can't simplify the square root of 31 any further, this will be our answer, I square roots of 31. So moving on to simplifying radicals where we can reduce. So if we look here at example D, and we're taking the square root of -90, we can think of this as the square root of -1 times the square root of 90. So this again gives us our I, but the square root of 90 can be simplified. So recall from your work the last 2 days that when you're simplifying a square root of a non-perfect square here, that you want to identify the largest perfect square factor. Well, if I were to do that, I would break this up into the square root of 9 and the square root of 10. Why? Because the square root of 10, its only factors are 2 and 5, and I can't simplify those, right? Cannot simplify those. Those are not perfect squares. However, the square root of 9 is equal to 3. And again, I have this I. So to write your final answer, we want to leave any square roots of non-perfect squares in the radical if we can't simplify them any further. And when we write our answer, put the coefficient first, then the I, then square root of whatever remains, which in this case would be 10. So real quick, same as I taught you before, we're going to type these in our calculator to verify our answer. Now our calculator, if you are using your TI-84 or your TI-84 app or the Calculate-84 app, then if you were to type in the square root of negative 90, you're going to see a decimal approximation here with an I. Oops, I didn't mean to hit that last one. Square root negative 90, and that's the approximated value. Now, to verify my answer, if I want to type in 3i square root 10, I would say 3. To get the I is located here above the decimal. If you look at your keyboard, there's an italicized I right here above the decimal. So we're going to hit second and then the decimal to get I, and then type in the square root of 10. And notice we get the exact same value. Now, of course, a shortcut might be that you simply leave out the negative altogether and just type in the square root of 90 and then 3 square root 10. But if you forget the I when you type your answer into Delta Math, it's going to be wrong, okay? Something I want to show you real quick, if you're using the Wabbit EMU app for the TI-84 emulator, or you have a graphing calculator, like maybe a TI-83 or 84, even if it's not a color edition, you would, if you were to type in the square root of negative 90, you're going to get an error message. In fact, it says non-real. Well, remember, not real means it's imaginary. So if I hit 2 to go to the problem, it's just recognizing that I can't take the square root of a negative. And the reason is because it's in real mode. So I want to hit this mode button, go down here to where it says real, change it to A plus BI, which, if you recall from your notes, actually the first day we did math in this course, we said that's the form of a complex number, complex imaginary number, A plus BI. So now when I hit enter, my calculator will understand it. Oops. Didn't even need to retype it. So notice, just like we got before on the app here with our phone, we get the same answer. Okay, so just wanted to give you that heads up in case you were using that type of calculator. One thing we also taught you from the video from yesterday was how to find square roots of larger numbers. So if I were simplifying this, the first thing I would do is, again, put an I out front, make it positive, and then simplify the square root of 294. Remember from the video that we taught you that if you go to y equals and type in your radicand, 294, and divide by x squared, so I'm going to hit x and then the squared button, x squared here. So I have, I'm trying to make sure you can see it, 294 divided by x squared. Then when I go to my table by pressing second graph, all I need to do is look for the last integer ordered pair. So I see 1 and 294, bunch of decimal values. Oh, I've got 7 and 6. And once I get down to the 1 point something, these 0 point something, I can't go any further. So my last integer order pair is 7 and 6. So again, if on my graph, or table rather, I have 7 and 6, we write that as 7 square roots of 6. So remember, it's always x root y, okay? And then just make sure you put the I in front of the radical. Okay? So if you are doing your work, which you will have to submit for the assignment in Delta Math, then please write this down. If you don't write this down, then I know that you haven't listened to my video to understand what work is expected of you. But I at least need to see that you are using your calculator and that you're taking the ordered pair 7, 6 and writing it as x root y to get your answer. Now over here for f, because I have the square root of negative 44, I'm automatically, sorry about the bell, going to put an I out there and make that a positive. Now this might be one you can do in your head, because if you break this up into factors, one of which being a perfect square, you can use 4. And then the square root of 4 is 2. So this would be 2i square roots of 11. Ideally, this is where we would love for you to get. So you either need to show work by doing this, or show work again by going to y equals, typing in 44 divided by x squared, looking at your table. Don't look in the negatives, by the way. Do not at all look in the table where your x or y's might be negative. Look down here in your positives. So we've got 1 and 44, 2 and 11, and that's it. So 2 and 11, again, if I were showing work, I would write x, y, 2, 11, and then make sure you write x root y, and that's how we get this answer. So that's really all there is to it. The only difference between yesterday's lesson and today is understanding that you have an I in your answer because you're taking the square root of a negative. So you can see down here I've got 3 problems that we've got in your Delta Math assignment. The first one is one that you might be able to easily do in your head. Number 7, you can't find any perfect square factors because 13 is a prime number, and the 245, you might just want to type that in your calculator. You can type all these in your calculator, but again, if you're getting to where we want you to be, then you're going to recognize that, oh, I put an I out front, and that this is the square root of 4 times the square root of 3. And that the square root of 4 is 2, then your I, then the square root of 3. So now I'm going to take you to hit pause, because I know you might think I'm talking fast, but remember to hit pause. And I'm going to go over to Delta Math and type this in. So I've got it pulled up here. Here's Delta Math. The problem we just did was number 1. So write the square root of negative 12 in simplest radical form. So I'm going to type in 2, and then I'm just hitting the I on the keyboard. Okay? Locate the K. Directly above the K is an I. It should be lowercase. I've already preset it so that you can just choose your radical there, and then 3. And then we're going to submit our answer. And it's really that simple. Okay? So they're even showing you here the square root of negative 4 is 2i, and then keeping the square root of 3. So next, for number 7, it's similar to examples A, B, and C. If you are still listening, put your initials beside number 7 over here in your notes. Just write your initials. For number 7, all I have to do is put the I out front, and I should have I square root of 13, because I can't simplify that. 13 is just 13 and 1. Square root of 1 is 1. All right, next for number 15, and we'll go back and type these in a minute, but for 15, again, I'm just going to put my I out front. And because 245 is a larger number, and I can't really find a lot of factors other than, well, it ends in 5. So what might I go with? I'm just going to use my calculator for this one. So again, in our calculator, let me try to make this where you can see it really good. We'll focus it so it's going to get blurry. Just a moment. All right. I'm going to type in 245. Notice I'm not putting in the negative. We already took care of the negative by putting the I out front. Divided by x, and then this squared button, squared. We are hitting the blue second button, then hitting graph to look at the table. And now we are looking for our last integer ordered pair. And I know once I get to the 1 point stuff and the 0, I just move back up and find the next one. So I see 7 and 5. So that means that if I've got, remember to show your work here, x, y, if I've got 7, 5, then if my answer is always x root y when I use this method, then it's going to be 7 square root of 5. I just have to remember to put the I in front. So my answer will be 7i square roots of 5. And remember, you can always, sorry about that, you can always type these in your calculator. So we're just going to go in real quick and type in 15, make sure you see a couple of other ones worked where we type that in. So we already said I, so I'm hitting the I on the keyboard, root 13. Submit answer. Yep. And then number 15. And we had 7i square roots of 5. And that's correct as well. All right. So if you've listened to the video, the whole video at this time, I want you to sign your name at the bottom like a rock star. All right. Sign your signature down there. Take a picture of your notes and go ahead and upload them into your 9/11 Simplifying Negative Radicands notes assignment. All right. Good luck.